really great to see such a big turnout. A lot of familiar faces, or familiar names, a lot of new ones. So we're going to try to make this as fun and dynamic as possible. We'll save some time at the end for questions, and also a lot of the stuff that we're going to be talking about is already kind of, a lot of these things are in the works in SqlDBM, and we're always trying to make a lot of these processes simpler, easier, faster. So we're also going to drop some teasers on upcoming functionality on the tool, how we can even automate a lot of this and make it even simpler. And we're going to be talking about database modeling, demystifying the word modeling, what it means, what it is, where you do it, when you do it, how you do it. So some of you have probably already seen some of the teasers we've done on LinkedIn and other platforms. So I promise no more modeling jokes, because I've kind of used up all of them. No more puns, no more metaphors. We're going to get straight to business. So passionate as I am about databases, about database modeling, I think about it all day long. I live it, I breathe it. But another thing I really like are cognitive biases. So a little armchair psychology. I'm always reading about them because it's fascinating to see how we as humans are irrational, but predictably irrational. And when you start learning about these cognitive biases, it's cool to see exactly where these little mental loopholes exist. And the answer to what you're already asking is no. Learning about cognitive biases does not make you any less susceptible to them. So you're still going to make the same boneheaded mistakes that your ancestors made on the savannah. But every now and then they can teach us something. So cognitive biases, I'm sure you've heard of the Dunning-Kruger effect, cognitive dissonance, the sunk cost fallacy. Today, we're going to take a look at an example of one called the curse of knowledge. So the curse of knowledge is, once you know something, it could be hard to remember what the world was like before you knew it. And there was a really, really great experiment done in Stanford in the 90s that tried to model exactly what this looks like in practice. So they took participants and they separated them into tappers and listeners. And then they had the tappers tap out a melody of a song, and the listeners had to guess what song this was. So we can play along. I'll be the tapper, and you guys try to figure out what I'm tapping. Here goes. Right, hold on a second. This would be, in fact, let me cue up the song because I'm going to play it in just a second. That's it. That's all I'm going to give you. Any ideas? Hopefully you can hear those taps. Any ideas what I was tapping out? Feel free to write in the chat or the comments. And if you didn't get it, okay, I see Smooth Criminal, not exactly. If you didn't get it, don't feel bad. It's a relatively, no, not Graduation song. It's a relatively unknown band and not one of their most known songs. It's an Australian band. You probably might not have heard of them. You hear that? Okay, so I guess some of you have heard of them. One of the most recognizable riffs in history, and if we hear this again, okay, yeah, I have no rhythm. Sorry. That's why I do database modeling. But now it's a little bit more obvious of what I'm tapping out. So that's exactly what the experiment demonstrated. The tappers were asked, what do you think the percentage of correct guesses will be to your songs? And the tappers said, on average, the answers tend to cluster around 50%. They assumed half the people, half the time, would get the song they were tapping. The reality, 3%. 3% of people, just like we don't have a large enough sample size here, but 3% of people actually got the song. So it's obvious in hindsight, not so obvious when you don't really realize what people are looking at. So how does this relate to modeling? Well, the answer is just like in this experiment, you tend to overestimate the final result if you already know the answer. But most importantly, you tend to underestimate the difficulty of the question itself or the difficulty of the problem. So in this demo, we are going to model an existing schema. We're going to add a new dimension. We're going to automate everything through dbt. But before we even dive into what modeling is, we are going to be using the TPC. Let me just jump in here. The TPC-H database. So on Snowflake, but it's a standard data set that you can use on any database. So none of what we're going to be doing here today is going to be Snowflake specific, but just so you're aware of, you can Google this and play along either on Snowflake sample data, or you can download this data set yourself on any database that you're comfortable using. So maybe I should have introduced myself. My name is Serge. I'm a database architect by trade, so modeling is kind of what, at least I thought, is what I do. And I'm also a development advocate for SqlDBM, the online database modeling tool. And I am also, well, I guess as part of my job, I transform data, I load data, I shape it, I sculpt it, I define it. And I thought I knew what modeling was because I put it on my CV, on my resume. So obviously I have to know what modeling is. And looking at a database like this, I would usually say, okay, well, I've been working here for quite a while. I know what the tables are. I know what the relationships are. Let's get to modeling. Let's get to transformations. But in reality, a lot of times, you would jump straight into a tool like dbt and you would say, okay, just give me the schema. I'll figure it out. But what happens when you open a schema and you have nothing? There's no tables, there's no views, there's no data. There's nothing to transform, which doesn't necessarily mean there's nothing to model. So let's look again at this example of, we're going to be using a typical manufacturing data set. So we have line items, we have parts that we buy, parts that we sell, customers. So there's always going to be some kind of application, an OLTP system, transactional system, an application that generates your data. Because again, before we've really started doing anything, our data warehouse is blank, it's empty, there's nothing there. We haven't, our business is just starting out of the garage. We haven't sold any parts yet. We don't even really have data. And where does it come from? So it's like asking, where do babies come from? If you're not ready to have that conversation, you say from the maternity ward, from the hospital. And it's true, you're not lying to your kids. And the same thing really happens oftentimes on the data warehouse side. Your data warehouse team says, where does my data come from? And you say, Airflow. Yeah, Airflow brings it. And they say, okay, sure, yeah. Just make sure it has a load date and I'm good. But we know better. We know that data does not come from Airflow. It doesn't come from Fivetran. It comes from the source system. So let's assume we are working with this data set. So let's look at it here in Snowflake sample data. Great, we have 7 tables and fairly self-explanatory: customer, nation, orders, parts, region. I can kind of figure out that region and nation are connected. Customers probably make the orders. That's great. But even now I've got something to point DBT at and say, okay, here's some data, here's some tables. Let's do some work. But I don't necessarily know, what does a unique nation represent? I can take a look at this. I can try to figure out what the data looks like, but it's not. Oops, that's orders. It's not ideal. So I'm only guessing as to what the primary key is, what is a unique record, etc. So let's take a look at the documentation, because that's a good place to start, right? You have all your OLAP system and the database. And okay, so now we have a relational diagram. We know the foreign keys, what this is trying to tell us. So part key is used in part supplier. Let's use some simple. Nation is related to region through the region key. That's great, but I still don't know, is region key a unique identifier? We have 5 values, but can they repeat? Do they repeat? Over here in part supplier, we have 80,000 values. But are they unique, and are they unique by these 2 keys? We don't really know. So this is where modeling really begins. And it begins in something called, it's a process called the bus matrix. It actually begins way before that, when you start thinking about your business. What do we do? Do we sell parts? Do we sell tickets? What do we sell? Popcorn? What does our business look like? What are the dimensions? Who are our customers? And that's when some of these details really get fleshed out, because this isn't born overnight in a single flash. You start step by step, and when you start, your steps look like this. There's nothing. You say, who are we? What do we do? And then you say, okay, well, we're going to sell parts and to customers. So you identify what are the dimensions of your business. We're going to have customers. We're going to have an order system which tracks them with line numbers. We're going to operate internationally, both selling and buying. We're going to group those into regions. We're going to have orders. We're going to sell parts. We're going to keep track of the stock. And who are our suppliers? So great, we have our dimensions. And then you identify the business process that uses these dimensions. And you always go one by one. You never want to try to do everything in a single swoop, because you're going to make mistakes. Simple as it looks, this is something that, again, I'm showing this for demonstration purposes, but this is something that I would sit down with the business experts, the business team, and before we even talk about tables and data types, we would figure out what these things are. How does our business work? And these people would tell me that when we purchase an item, we create a line item, we place an order, we order a part, and then we also reflect that in our stock, and we go through a supplier. So now I'm ready to model this as data, as tables, which can capture this type of activity with adequate primary keys and adequate data types. So this is kind of where we are now with the existing business. This is what we do. We sell parts, we sell stocks, we keep track of stock rather. We have customers, customers make sales, they make returns. We do some sales forecasting. So some of these you'll notice different processes. They use the exact same set of tables. So a sale and a return are essentially the same business process, just in reverse. And so you can have multiple business processes pointing to different or similar parts of your business, which are the dimensions. So back to the diagram, this is starting to make a little bit more sense. I'm starting to get an idea of what my business is, how it operates, and what it does. But I'm still not clear on if I'm asked to denormalize this data for easy querying or add a new business process, what would that actually look like? Because I don't know my primary keys. So what I've done is I've started making a proper relational diagram to help me understand that. I've done my due diligence. I've checked with the business what are the unique records, what are the unique identifiers, do we have a transactional system where some of these are recorded, and what are the business rules. So that takes me to a relational diagram where, again, same thing that we just saw earlier, but much more explicit, much more intuitive. So if I go back to nation and region, now I know for sure that yes, nation key is a unique identifier for nation. There's a foreign key, they're related by region key. So my business tends to group nations into regions with a name, and so on and so forth. So I have customers who make orders, who are then recorded as line items because they purchase supplies and parts which come from a supplier, etc. So now all of this is fluid and intuitive. Just by taking the same diagram, essentially the same information, I'm able to generate a lot more insight into how my business operates. And this kind of takes us back to that initial example of, now that I know this, I can easily work with my data. Now it's obvious that region are a grouping of nations, but just a minute ago I didn't know that. So just like tapping out the song, if tomorrow a new hire joins my organization and I tell them, yeah, just denormalize nation and region. Even something like that is not obvious for someone who hasn't worked with this data. So until you do things properly, until you document things properly, it's really hard to expect other people to understand the same thing that you've understood. Maybe I've been with the company for a number of years, so I can do this in my sleep, but some of my colleagues haven't. So let's go back to the bus matrix and let's define a new dimension, a new business process. So we have sales and we have customers, and now that we're a growing business, we decide that we want to add a loyalty program. So the loyalty program is basically just going to reward frequent shoppers with discounts. So we know we'll be analyzing our customers, we'll be segmenting them somehow. And for that, we're going to need a loyalty level. Once we've established what those business rules are, we're going to need to record that somewhere. So we sit down with our domain experts, our business team, the sales team, and we say, how would you like to assign loyalty to the customers? So they say, well, simple. We're just going to analyze orders, and we're going to see who our top customers are, and we'll create a tiered structure of how we reward them. And there's a couple of guys that were with us from the very start, so they're not big companies, but we really appreciate them, and they're part of our loyalty program too. Okay, so at least we've identified the dimensions, and we know the business process, and that we'll be creating a new dimension to keep track of this. And again, this is where we can jump straight into a data model and both help us think about this and also at least give us the initial blueprint of what we are going to build once we start defining that business logic. So let's create a new diagram and create a table called loyalty, since that's what we're going to be working towards. And loyalty is going to have a loyalty ID, and just want to make sure I don't screw this up since I've already defined it to a specific standard. Let's just move this out of the way, zoom in. So let's give this a loyalty key, since we're doing certain naming convention. So let's make that a bar chart. And what else are we going to put into loyalty? So we'll definitely have the customer, since that's what we're working with. We're going to need to keep track of who the customers are that we're rewarding. And with customer, let's bring that onto the diagram. So we know that they're going to have a relationship. So customer is going to be parent, or in fact, let me do a non-identifying physical relationship. So this way we have customer key. We already know, we've defined what a customer looks like. And besides that, we're going to have a loyalty type and a loyalty name. Keep it simple. So L type. So let's make that a varchar, something descriptive. The business have told us that the loyalty is just a three-tier system of bronze, silver, and gold. So L name. And let's make that a varchar as well. And a comment just in case, because why not? So there we go. That's at least that gives us a blueprint for what we're creating, because if we dive right into DBT, we might know the business process, but we still don't really know, did we define a key that we want to keep track of in the source system, what the actual types are, etc. And we also know the relationships of customer, and this will have orders which are linked to customer. So in order to do this join, again, we can simplify it for ourselves. Order key is a foreign key in, customer is a foreign key in orders. So we know that we can join this quite easily using these columns. So let's jump into this. DBT, just going to give a very brief overview in case some of you are unfamiliar with it. DBT is a transformation tool. So they describe themselves as the T in ELT. So they need data they need something to transform. They're not going to create data out of thin air. They use existing data that we've modeled in our database. So we're using the customers and orders data, which we already have from the sample data, and we would like to build this process. So this is where the actual transformation takes place. This is where we add our business rules, and we define this, we build it, we test it, and we integrate this back into our models. So to get started, the first thing we need is a list of sources. So DBT works in a very modular fashion. So it tends to abstract the physical objects, as in tables and views, and it works with models or concepts, logical concepts of what is an employee, what is a customer, what is a loyalty, because the physical part is almost irrelevant. Today it's a table, tomorrow it could become a view. It really doesn't change the underlying logic of the actual element. So when I'm defining sources, first I'm going to just say, where am I pulling this data from before I start transforming anything? And in this case, we're working with a format called YAML. So let me just create a new branch. So add loyalty. I'll just refresh this. It's been open a while. Okay. It's not good. Is there yes. I did call my project just meshing around. Maybe that's why. Oh, because I think I probably had to add loyalty before. There we go, duplicate name. Back to business. So just to explain what we're doing here, we are defining our sources. So sources we know are the orders and customer table, and we're going to build a loyalty table out of that, which means as part of our YAML, I can create these things, and we kind of went a little quickly here. We didn't add any descriptions or anything useful, but this is where, before I even start working, I can have the information about orders and customers pulled directly from the DDL. So always try to keep your comments in the table itself or in the object itself, so the database, any third-party tools like DBT can reference them. So in this case, I've generated the YAML beforehand, which is just a description of the table name and the list of columns and the descriptions, which again, I've failed to define, but in a normal scenario, these would also be filled out directly in your modeling tool. So I have my sources. Now I'm ready to make my changes. In the models themselves, let's create a new one called loyalty.sql. So this is what I was saying earlier. We are creating a model called loyalty. Maybe we don't even define yet how it's going to look. Is it going to be a table? Is it going to be a view? We'll see what the performance is like. And all we really care about is the business logic. So the business logic looks like this. As DBT suggests, we're going to start with CTEs, which allow us to work in a modular fashion. So we define our customer as selecting the necessary fields from the customer source. And what is this? This doesn't look like SQL to me. This is Jinja. For those of you who are unfamiliar with DBT, it allows you to mix small elements of Python with your SQL. So I can include a Python reference to my source, and again, building on that modularity. In case currently my data comes from a table called customer, tomorrow it could be customer CRM or customer Salesforce. I can still keep this link, the link to the actual element, the same. I would just have to change one little thing in my source and I can keep working. And the modularity with CTEs allows me to also have that flexibility in my actual development. So orders, I can make that a little bigger. Orders, same thing. I reference by source, and then I start linking them together. And how do I link them? Well, that's easy because we know what the key is. We can see it in our model. Customer key and orders, and C cust key and O cust key. So this just saved me a good 20 minutes of trying to figure out, is this unique? Is it common? These start with different letters. Are they the same field? Now we know, yes, they are. So all we're going to do is, as the business have told us, we want to know what are the orders for our top clients by purchase price, and we're going to pull those from orders. And we're going to add some business logic. So we've already joined the two elements. And we're going to say, first of all, account balance has to be greater than 0. So no deadbeats. And guess what? Nation key 22, Russia, get out of here. We're sending a strong message to Putin. No loyalty points for you. So hopefully that'll discourage what he's doing over there. So that gives us our orders. And now let's assign the loyalty to our clients. So what are we going to do? We're going to take the output of this, and the great thing about CTEs is I can test this independently. Instead of one big block, I can just do a select at the very bottom to see, instead of from rename, I can pull from customer orders and see, okay, what are the top customers given this logic? I don't have to rewrite all my SQL every time something changes. And the business logic basically says, rank over them, and when it's between 1 and 20, those are my gold customers. When it's between 21 and 100, those are silver. 101 to 400, bronze. That's my loyalty level. and we're good to go. And don't forget about the early supporters, which are hand-defined values that we remember since they were our early customers and we don't want to forget them. So give these guys gold status regardless of how much they contribute. So the final loyalty program is just a union between the rule-based set and the early supporters. And the loyalty key is just the first letter of their loyalty level and their customer key. So it's very easy to keep track of. And the very final thing we do is just rename this for clarity. And exactly what are we renaming it to? This is why we had the blueprint earlier. So we know the loyalty key, we know the customer key, we know all of these names, all of this naming convention. And let's just run this as a preview, see what the data looks like. Does everything work? Does everything compile? So for those of you unfamiliar with DBT, once you hit run, it does a compile and it transforms anything in Python or in Jinja to actual SQL. So yes, here's our data set, and this is the result. And you can even see the compiled code in case you're confused by this source. It just gets evaluated to the table which we defined in our sources file. So that's great. Looks like we have loyalty done. Save. And so we haven't really done any transformational modeling. We've done a transformation which we modeled in our diagram before we even got started. So let's go ahead and do an actual transformation-based modeling. So transformation-based model, I meant to say. So what did we have earlier? So we have part supplier, for example, that has the metrics of availability and cost and how many parts we have, but the actual metadata of, or not metadata, master data of who are the suppliers, where are they located, what is the brand of the part, etc. That's in separate tables. And I'm tired of making these joins every time I want to know. So I want to denormalize these. And here we're all pointing to the source schema of where our data resides, how it lands from our source database. And now we're actually getting into data warehousing. So making an analysis or making things easier to query, denormalizing, etc. So let's make a denormalized table with all of these three elements. So the sources we already have, since we've built those previously. And let me just grab the SQL. And go back to here. And let's create a new file called parts supplier.sql. Great. So again, this is a very simple, just a denormalization of all the columns. We know the joins based on the primary and foreign keys, which we've previously documented. So it's very easy. I don't have to, again, search for all of these relationships. They're done for me. And let me just hit save. And previously on this step, we've tried our logic. It works. Are we done? Not exactly. So we've just created the model for loyalty. But now it's time to, once we've verified the result, it looks great. It's time to integrate that back into our existing diagram. So we've just built a new element. So just like what we've done here, we want to make sure that all of this information is not lost when we forward engineer or when we build this model in DBT. So we already know that it has a relationship to customer. So we know the loyalty key is the primary key. So we can go and use the forward engineering to save ourselves that step and say loyalty, save. generate SQL, get these constraints, and make sure that once we've already done the work, this information is not lost. So let's bring this into DBT as well. So with DBT, this becomes a config block. So I'll just type it up here. So we've determined, yes, let's keep this as a table, and let's make sure that the constraints are enforced as well. So it makes everyone's life easier when you can see that what a table's primary key is directly in the table itself. So let me hit save. From here, I would do dbt run. Well, we've already tested that it works. I'm just going to skip ahead a little bit since I've already done a lot of the tedious work of making a YAML file with all of the documentation, which will likewise be applied directly to the table. So it's not just in DBT. So if we go back to loyalty, we have a very basic data lineage here, which is great. I know that I'm using customer and orders at a glance to make loyalty. And how am I doing this? Well, SQL is really the best explanation as to how. All of the logic is here, it works. I know what it's doing, I can understand SQL, I don't need another abstraction or a simplification over that. And I want to make sure that, again, I've just done this, and I want to make sure that none of this is lost, because tomorrow I know I'll forget and someone else will come along and not even remember in the first place. So that's why we want to make sure that all of this information is, again, this is YAML, and this will get tied right back to the table once we deploy. So let me commit this, done. We've created our two models, or rather we've created two models. One of them is data warehouse, and the other one is kind of part of our original enterprise system, OLTP system. Now I'm ready to run these. So if we go to jobs, I've already created a job that runs and deploys these two models back to my database. So I can just hit run, but I won't bore you with the details. The important thing is once they get deployed, are we done? No, we're not, because it's, for those of you who have used DBT, DBT takes those YAML files and it keeps documentation and easily searchable. For example, if I type here loyalty, it'll take me straight to the model. I've documented really well, so I can understand what I'm doing here, the business logic, the loyalty tiers are here, and if I still have any doubts, I can go all the way down to the actual SQL and review. And I have lineage graph, which is fantastic. But again, I'm only seeing what I did in DBT. So I defined loyalty, I've defined part supplier. I don't see the big picture. So another big part of modeling is not just creating the elements or defining the model, but it's mapping. It's mapping everything back into a single source of truth. So given that I've already done the work, I've created the object, I can just as easily come in here and pull these things back into my model. Again, everything is a model, but they're just models of different kinds in this case. So now that I've got final DDL, I can do a reverse engineer. I can connect directly to Snowflake, but I've already got the DDL handy, and import it right back into my project. So loyalty and part supplier, import. I've actually created part supplier in a different schema, so it lives separately. It's part of the data warehouse schema. And now I can go back to my diagram and say, now that we've got everything defined, part supplier, what does that look like? Even though it's in the enterprise data warehouse schema, I can still show it with its relationship to parts and suppliers and the documentation, which we'll look at in a second. Loyalty, likewise, I can bring that onto the diagram and say, okay, that's a process tied to customer. And loyalty is actually tied to more than customer, it's tied to orders as well. So that information is not reflected in the relationship here. So because I've already done that work in DBT, first and foremost, none of that work and information is lost. So as part of that reverse engineering process, I've been able to capture all of those descriptions that I've added and left at the database level as DDL for both of these tables, part supplier and loyalty. And at the end of the day, what I can also do is, if I wanted to, even though this is in DBT now, I can complement my relational diagram with the actual operational logic. So besides just tables and views, I can also do logical objects like procedures and functions that if I wanted to explain all from a single place, I mean, we're using DBT, so we can always rely on this documentation and these lineage graphs. But otherwise, if I had a Snowflake task or a Snowflake stored procedure to do this, I can also put that into the diagram as well and connect it to exactly the processes that it involves. I mean, I wouldn't want to do it all on this one busy diagram, but I could create a separate data mart to show, look, this is not just the relationship between customer and loyalty, but here's the actual logic. So as promised, after the demo, I promised to tease some functionality. So what I've just described, let me just share my screen. What I've just described is an upcoming feature that we are releasing next week. Stored procedures directly on the diagram. So I didn't want to dive into dev and show you something that's not ready to see the light of day yet, but it's going to look something like this. So you can see not only that two objects have a relationship, but you can actually click into the relationship itself and see exactly in SQL terms what it is and how this transformation happens, let's say from a source table to a type 2 slowly changing dimension. And understanding that some of these procedures can get quite complicated, this one is a little bit further away. It's a few weeks away, but I think it's worth waiting for. View column level lineage. So you'll be able to navigate your entire procedure, script, view, and see step by step exactly all of the intermediate steps in your data. So not just a little box with the SQL, but visually a lot quicker to see exactly how these things change and interact. So that's a lot of talking. That's what we're doing. And the other big thing that I was hinting at is the initial process that took me from relational modeling to DBT transformational modeling, which was this YAML file. This is also coming very shortly in the forward engineering screen. So on forward engineering, we're used to generating SQL, either the create command or the alter. And very shortly, we'll have another button to say, look, I'm about to make some transformational modeling using parts and suppliers and some other tables. Give me that YAML already pre-formatted. As some of you know, it's a very finicky format. If you skip a space or add a tab, you've just broken your entire project in DBT. So this will allow you to pre-generate that, as always, neatly formatted, error-free, with all of the descriptions that you've previously entered into your project, and continue working, basically never losing any information, both metadata as well as relational information. So that's, look for that next month, perhaps. I think it'll be next month, 2 months should be ready. And let me stop sharing and answer some of the questions. So yeah, next week is Next week is we have a lot of exciting things happening next week. We're doing the stored procedures and connections on the diagram. Also flagging. A lot of our users have asked for flagging, so things like creating categories like PII or sensitive information or email, financial, whatever. You can tag your columns or your tables and then filter based on those to quickly find exactly what are your sensitive fields and things like that. So that's all next week, and some of these other features are really close. I wish I could demonstrate them live, but they're still in testing. But that's the idea. So keep your eyes peeled. Stay tuned. A lot more to come. And do we have questions? Yes, we do have some questions. So let me go through some of these. If we're using DBT for transformations, do we still need SqlDBM? I would say absolutely. I am a little biased, but I would say absolutely, because as we've just seen, we created 2 elements in DBT and it was quick. We did a fantastic job, but what allowed us to do it in a matter of minutes? The fact that we already knew what we were building. And once we built it, again, we are looking at 2 elements in our DBT project, which, as far as DBT goes, are 100% documented and clear, but we don't see the bigger picture. We don't see a diagram of all our sources. We don't see how these things tie back into the overall database landscape for future use. So keep in mind that same example of the tapping, that it's obvious what we did because we saw ourselves do it. But tomorrow someone's going to come along and say, why did this work? Why did this happen? Who did this? And how? How does this tie back? So this is that journey from modeling relationships to modeling the transformation and then mapping/modeling the overall end result. So I hope that answers your question. And should the data definitions be coming from our data model, or can they be part of the DBT process? Well, the data definitions, this was asked by Anonymous, so I'm not really sure what you mean by data definitions, but if you're referring to the business logic, then the name kind of gives it away. It's determined by the business. I'm not the one who determines who's gold and who's the initial customer. So this is kind of a simple example. The business will be very clear in terms of telling you exactly what they need and exactly what all the exceptions are and who needs to get grandfathered in to the loyalty program, and et cetera, et cetera. So you'll have no shortage of definitions of when you're building new elements and new models. How can one of these tools to build the analytics platform? Well, the analytics platform is just what we've seen, but in large scale. So we just took a single business process, we modeled it, and then we took a single, analytics model, which is denormalized the parts and suppliers, and we created that, and we brought that back into our overall landscape. And that just gives you an idea of the types of transformations and the types of modeling that will happen in an analytics platform. But an analytics platform they're monstrous, they're beastly, they grow to proportions where you need these tools. You need these tools to keep track of them, because now it's not even a question of the curse of knowledge anymore. It's a question of there's just no human brain that can keep track of all of them. So you need to, as early as possible, that you can get on the best practices of keeping things documented, keeping things visual, neatly organized, accessible. That's gonna keep all of these things in check. So I'll try to get to all of these, just three more. So how can we keep these? Oh, this one we did. And how can we create tables and views on Snowflake with automated process with Stitch and DBT? And how does SqlDBM? So I think I mostly answered this one. SqlDBM will automatically pick up through reverse engineering anything that you land into Snowflake. And that's going to allow you to, before you jump into transformations, because obviously you're going to want to think before you measure once, cut twice, as they say, you need to understand what you're building. So having something like let me just share my screen. Having something like this makes any kind of modeling work easier. Again, we've got eight or 10 tables here. So it might not be that obvious that we need help, but imagine when this grows to thousands of tables. The ability to search, the ability to find exactly what you're looking for and zero in on exactly that element and understand how it relates to its predecessors is very important. And I think there was one other comment, one last question. Performance. Yeah, so performance on the diagrams with very busy objects or very busy models. Somebody has thousands of entities and tables, so exactly what I was describing. So we're looking at a very simple example, but a typical enterprise data warehouse will have hundreds, if not thousands, of tables. And the answer is performance is quite good in SqlDBM. Even once you reach into the thousands, we can comfortably support up to 3,000, a little over 3,000 if my memory serves me, elements on a single diagram. If you wanted to put every single database object there, and even after that, it's not a hard limit. It's that's when you might start seeing some slowdown. So it's going to depend a little bit on the system because it is running in the browser. So on our backend, everything, there's no limit to how many objects a project could have. It's really how much can your computer support on the screen at any given time. But that having been said, we've seen the kinds of DDLs that our customers bring to some of our demos, and they do get beastly, but they run just fine. So yeah, I think if any of you are curious, you're welcome to try the tool at your own pace, schedule a demo, we can set you up with an account. Feel free to play around and get a feel for how it works. And I think, what else do we have? How to put business definitions and name parent-child relationships. Okay, let me share my screen again. So in terms of the definitions, so what we were seeing earlier, if we go, for example, to the parts up thing that we created, let me just bring back my panel. So everything that we did in DBT has not been lost. So if you see in the descriptions, all of the descriptions that we provided, all of this business information, formulas is not lost. It's been recovered in the reverse engineer, which is why it's so important to keep track of it, given that you have the right pipeline in your tools to make sure it doesn't fall by the wayside as part of your design process. So we have it here. We have a dedicated database documentation screen where you can search for things like loyalty all the way down to the description level, and it'll find anything you've defined. So if I look for bronze, that's not obviously a column, it's a description in my loyalty type column. So that's why it's really important to, once in the moment that you're defining it, just comment your code, but also comment your elements. That way somebody comes along and say, well, yeah, I know we have a type, but what types are they? And this will save them having to go and analyze and see what's actually available. And in terms of naming parent-child relationships, if I understood the question, we do have the ability to decide how those are named as well. So for example, primary keys and foreign keys. Not only can we basically say the static part, they should all start with PK underscore or foreign keys. We can even use expressions that will automatically name them in context. So for example, if I'm creating a foreign key, I can make sure that it has the parent table and the child table already in the key name separated by underscores. I can even go down to column level, and I can apply that even to existing objects or just validate this for new objects going forward. So if that was your concern, then that's the answer. And what else? Do we have any other questions? I'm happy to take them. And if not, we can end it here. I really appreciate all of you showing up. It's been a great turnout, and I really appreciate the questions. And I hope I've made this fun for everybody, and I really appreciate you coming. So thank you very much.